Hello and welcome back to my channel Code with Ease. Today, as part of the Recursion Primer series, we are going to solve how to remove adjacent duplicates in a string. Hi, here's a brief introduction for the ones who are new to the channel. The objective of Code with Ease is to make problem solving in programming simpler. If you are someone who wants to become a great developer and wants to level up their skills, data structures and algorithms is indispensable and you need to form a solid foundation of that. And this is exactly where we come in. Because we post topic-wise video explanations in Java on various coding interview questions that can not only help to crack the coding interview, but also help to improve and refine the problem-solving abilities as a developer. And finally, here is the USP of our channel. We code every solution live, we do not copy-paste code snippets. We start off by clearly defining the problem statement, the given inputs, the required output, time and space complexities. We also then discuss the brute force way of solving any question without jumping on to the solution and then gradually move on to the optimal solution. We try to use online whiteboarding wherever applicable to explain the approach and the concepts. So that is all about us. So if you guys also want to be a part of this journey, do support us by subscribing to the channel. So with that, now let's get back to the question. In this, we are given a string and we are going to remove the adjacent duplicates. As we can see, initially we are having 4 occurrences of the character A, but we have to keep only 1 occurrence because all the A's are adjacent to each other and we want to remove the adjacent duplicate occurrences of adjacent elements. So we'll keep 1 A. Then we have 1 B, which is fine. Then it is followed by 2 C's. So we want to keep 1 occurrence of C only. Followed by B. Then again we have 2 occurrences of A. So we'll keep 1 occurrence of that. So this is our required output for this given string. So now let's try to see how can we solve this question. Well, before we move on further, if you guys are enjoying the content so far, please hit the subscribe button and press the bell icon for the notifications. Continue watching the video till the very end, and if you find it useful, please hit the like button so that others can also get the benefit out of this. So let's continue. So whenever we talk of thinking recursively, first of all, we try to break down every recursive question into 2 parts. One is the base case and second is the main body. The base case is what has the condition of stopping the recursion, because if it doesn't, then it will go on till infinity and cause a stack overflow. I'll try to link up in the description the entire playlist and also that specific video of the Recursion Primer series, the starting video, which has all the necessary things that we need to know for learning recursion. I'll link it up in the description also. So base case is nothing but the condition which will ask the recursion to stop. Main body, on the other hand, is going to contain that logic which is essentially going to do the actual recursive calls and also some additional logic. So apart from having the logic of doing the actual recursive call, it is also going to have some more logic. So that is what we segregate as a main body. Now, in this case, if we try to think of this question in terms of loops or iteratively, why I talk about loops in the beginning, because the first way of trying to learn recursion or trying to think recursively is always to think of the iterative approach. That makes it very easy, because when we think of the iterative approach, converting that iterative approach to a recursive solution makes more sense and is quite relevant and easier to do. So if we think of loops, if we have to do this question, solve this question using for loop, what we have to do, this for loop will start from I equal to 0, I less than n is nothing but the length of the string. So inside this loop, what are we going to do? What are we going to check? If any element or any character is adjacent to each other, we check I is whether I is equal to I plus 1. When I say I mean string n dot caret. I don't want to keep this as n, I will keep this as size. So this n is the string that we have as input, n dot char at of I. So this character, we want to check it with the I plus 1th character, same thing. So I'll just write it also, n dot char at of I plus 1. So this is the check that we want to do for adjacent characters. If this character at I and I plus 1, whether they are equal or whether they are not equal. If they are equal, we should skip it and go ahead. If they are not equal then we can add to our output string. So how will this work? So A and A are equal, so I will not add anything to the output string. The moment I come across A and B are 2 different characters, is when I will add to output what? I will add to output the n dot char at of I. This should be added. So Overall, this is the kind of the way of thinking when we are trying to solve it using loops, that we'll have one for loop to traverse through the array. We will check the adjacent elements, and then based on the condition, whether it is equal or not equal, obviously if it is equal, we are skipping it. If they're not equal is when we are adding to our output string and thus forming a new output string which contains single occurrence of every character. No duplicates, no adjacent duplicates, I mean. So in short, this is the way to approach this question using loops. Now we have to try to think of this in terms of recursion, because that is what we have to do. So I'll comment this out as of now. So inside this main body, we try to solve the smallest subproblem. What is the smallest subproblem? In case of adjacent duplicates, like we have 4 A's over here, in case of adjacent duplicates, we will skip the duplicates, and only when I and I plus 1's characters are different is when we should consider that ith character. That is the smallest subproblem. To grab the n dot caret I, that character which is the unique one and not a duplicate, adjacent duplicate, that is the smallest subproblem. So in the iterative way we were adding this to an output string, we can also declare a global variable and add it to an output string, that is number one, or we can pass in an extra parameter called output and try to manipulate that string or try to append the characters inside that new string, or we can also inside this function only we can try to print out the every character. So inside the main body only we can print out, instead of doing print ln we can do a print where we will print n dot caret of what, not I, will print the 0th character. But this we are going to print based on some certain condition. What is that condition? If n dot caret, okay, remember we are trying to solve the smallest subproblem now. So I know there will be many questions that's going to come, but we are just focused on solving one small subproblem. We are saying if n dot caret of 0, forget everything else, just consider this, the first A and the second A. If n dot caret of 0 is not equal to n dot caret of 1, if they are not equal means they are not adjacent duplicate, is when I should be printing this n dot caret of 0. Why 0 and 1? Why am I hard coding? I cannot use I over here. I we were taking as a reference variable because we were traversing through the entire loop. Inside a loop we were trying to keep track of I. But in case of recursion, we don't have any access to any such variable which is going to be incremented. We can, for that we have to increase the number of parameters. One parameter for the output variable, one more parameter for keeping track of I. So that is why we won't do it like that. We won't increase the parameters of the method. Inside the function only we will try to do whatever manipulation we want. So since I'm talking of why I'm talking of smallest subproblem every time. Every time the string that we are going to manipulate inside this function, we will only be concerned about caret of 0, caret of 1. Only two characters at a time we are going to check. If this and this are not equal, then what are we going to do? Or if they are equal, what are we going to do? So in that case, let's take this string. If A and A are same, their adjacent duplicates, means we should be skipping the initial A and we should be concerned about this much of the string by discarding the first A. Again, second A and third A are same, so we should be skipping the second A and concerned about this part of the string. Same thing is going to happen in the next time. We are going to discard the third A and be concerned about this. Only when A and B, because they are different characters, because they are different, is when we are going to add or rather print out that element which is the fourth A and then proceed with rest of the string. So what is the pattern that we are seeing? We are discarding the leftmost element and continuing with rest of the string. This thing is achieved by a substring method. We are trying to chop off the character from the leftmost end and taking the rest of the string. So we are taking a substring. So that is why what we will do is, when we will call this function, we have to call this function to do the recursion, to repeat the same activity, but we will not call this on n. We will do n dot substring of 1. Substring is a method which takes in 2 parameters, 1 parameter. So there are overloaded version of this. If it takes 1 parameter, it is taking the begin index, and that begin index is inclusive. So if I am giving 1, means I am discarding the 0th character, the leftmost, and continuing with rest of the character starting from index 1 and the rest of the string. So this is what I am doing every time, right? I'm getting rid of the leftmost character and proceeding with the rest of the string. So that is why end dot substring of 1. So this function I am going to call again with the parameter change to end dot substring dot 1. When I am calling this function, whenever my end dot caret of 0 and 1, whether they are same like a and a or they are different like a and b, irrespective of both the scenarios, I am going to call end dot substring of 1, because in any way either I will discard that value, that character, or I will take that. If I am discarding, I am going to call this. If I am taking it, I am printing and then calling this. That is why I have kept it out of that if condition. So that is all. So that is the smallest sub problem that we are solving. What are we doing? We are concerned about two characters at a time, the characters at 0 index and 1 index. Doing this condition, printing out the respective character in case of a mismatch. In case, I mean, if 0 and 1 are not equal, I'm printing it out. And in the second part, I'm doing the recursive call. I'm calling this function with a changed or a modified parameter. So this entire thing is the main body, in which I started with the smallest sub problem and then called the whatever recursive function I have to call. So this much is done. The main body is completed. But is this enough? No, because I have to solve the base case also. What is going to be my base case? Notice when we are doing end dot substring of 1 again and again, at one point it will be last two characters, last one character, and then empty string. We should ideally be stopping when the string has become empty, because if the string is empty, what do we remove from it? What do we check in it? Nothing. So if the string is empty, end dot is empty, we will stop the recursion over there. So if it is empty, I'll just say return, because it is a void data type, so I don't have to return anything. So that's all about the base case also. So I'll just remove all this extra information and we'll try to run this. Okay, there is a string index out of bound, string index out of range. At line number 16. Okay, I think it's one of the edge cases. If I have C and B, so 0 and 1 are not equal, so it will add 0, it will print out 0. C will be printed. I'm left with one character B, and okay, yeah, I got it. If I'm left with one character at the last, I cannot, actually the base case is wrong, because if I'm left with one single character at the end, and if I am left with one single character, then that is when I should actually return the character or print the character and return, because if there is one character at last, then end dot caret of 0 is fine, but what about end dot caret of 1? The last character is, there is nothing after that. So this check will not happen. I mean, this check will fail. So that's why I should not be having this as the base condition. Instead, I can say if n dot length is equal to 1, means there is only one character that is left in this string, then just print that out, that character, just print it out, that will be n, and then return. It won't be, the base case will be for this. Whenever I will have one single character left, just print it out and return. So with that, let's try to rerun this. Yeah, so that is our required output, A, B, C, B, A, C, B. I'll also try to give some other, okay, and just change the string. We should ideally get A, B, C, A, B. Yeah, it works. So yeah, that was all about this question. How to remove adjacent duplicates from a string. Do let us know in the comments below if you guys have any questions or doubts, or you want to share any feedback on this video. If you have enjoyed the session so far, do hit the like button so that this can reach out to many more people, and if it does, it just gives us enough motivation to put out more such content. Also, if you are looking forward to more videos like this, please don't forget to subscribe to the channel and press the bell icon next to the subscribe button to never miss an update on our upcoming videos. Thank you so much for watching.